Hey, what's up, Room 10? Here we go again, going for another science lesson today. So I'm going to have a little video up here that we're going to walk through once we read these two pages. So go ahead and get out your science books, open up to page 66, go ahead and hit pause on the video, and then once you're there, go ahead and hit play, and then you'll just jump right up here with me. Cool. Sorry about that last video. I filmed that whole thing, and for some reason the iPad decided to go ahead and change the focus on me. So hopefully that doesn't happen again, or I might cry a little bit, just a little. All right, sweet. Here we go. Classifying matter. So at the top of page 66, let's read through these two pages. All we got is 2 pages a day. Should be able to rock and roll pretty quick. All matter is made up of small particles called atoms. These atoms are much too small for you to see. Most matter contains more than one kind of atom. The paper used to make this page is made of different kinds of atoms. Your chair at home is made up of different kinds of atoms. You are even made up of dozens of kinds of atoms. Some matter contains only one kind of atom. Matter that's made of only one kind of atom is called an element. Element's one of those vocab words you're going to be writing down, putting the definition with it. So an element is a substance that is made of only one type of atom. So gold, silver, oxygen are all examples of elements. They are only made of those types of atoms. Scientists have named more than 100 different elements, and when you get up into junior high and high school, you'll have to memorize them all. So yeah, that'll be a good time. We don't have to do that in 5th grade though, so you're good. Atoms may join with other atoms to form particles called molecules. Remember last week, I think it was last week, when Mrs. Gutierrez from the Riverside Public Utilities came, she shared with us about molecules. Remember, she talked about the water molecule, how it was H2O. So we have one big oxygen atom, and then we have 2 hydrogen atoms that are stuck to it. And then remember, it takes like a billion billions of molecules to make like one water drop. That was pretty crazy. I always love like the picture in the book of the molecule for the atom. I think it looks like Special Agent Oso. I think you know what I'm talking about. This Special Agent Oso. It's good cartoon if you've never seen it. It might be a little too young for you guys. Now, atoms may join with other atoms to form particles called molecules. Air contains molecules of oxygen and molecules of water. Let's jump down to, we'll keep going. Each molecule of oxygen contains only the element of oxygen. However, each molecule of water contains 2 elements, hydrogen and oxygen, together. Substances such as water are called compounds. A compound is formed by combining atoms of different elements. A compound is a new substance, so it is something completely new. Once the 2 different types of molecules have come together, it makes something completely new. It is different from the elements that formed it. So an example of that is water is different from either hydrogen or oxygen. Both hydrogen and oxygen are usually found as gases in the atmosphere or around us. Hydrogen is an explosive gas that burns easily. So let's think about that. So you have hydrogen that makes up water. This by itself burns very easily, but yet when it's mixed with the oxygen, it puts out fire. So you see how that's kind of crazy? So with it by itself, it would burn, but mixed with that oxygen, it puts a fire out. And oxygen's the same way. Oxygen's needed to help many things burn. So it's kind of crazy that one thing is flammable, the other thing makes fires burn hotter, but when you mix them together, it puts fire out. It just kind of seems like it shouldn't work that way, right? Okay, so we're at the top of page 67 now. Every molecule of a compound is identical. But for example, every molecule of water is the same. Every molecule of water always has two atoms of hydrogen and one atom of oxygen. Now, compounds form through a chemical change. Chemical change is very important. Remember, physical change, you were physically changing it to something else. So if I took a piece of wood and I hack it to bits with a little axe into a bunch of little shards, it's still wood. It did not become something new. It stayed the same. I just physically changed it into smaller shapes. Now, if I take that wood and I burn the wood, then it's going to be a chemical change. So let's look at the definition here. It says a chemical change is the process of two or more elements or compounds combining to form a new substance. Unlike a physical change, a chemical change causes the elements or compounds to lose their individual properties and take on new properties. For example, the elements sodium and chlorine are both poisonous to people. In their most natural elemental form, they would both be dangerous. But when those atoms are joined together of both those types of elements, however, they basically make the compound that we put on our food to make it taste good, salt. So you can often observe the effects of chemical changes. Rust is a great example. So you have an iron tool, it sits outside, it gets lots of rain on it, the water mixes with the iron and it causes rust to happen. That is an example of a chemical change. Chemical changes can also occur in your kitchen. A cake is the result of a chemical change. The properties of the flour, the eggs, and other ingredients turn into a tasty substance. Cake. All right, cool. So let's see, we got 1, 2, 3, 4, 5. We got 5 vocab words on these pages here. Chemical change, compound, molecules, elements, atoms. And then we got 3 quick track questions down at the bottom of 67. Cool, so this video real quick, we're just gonna watch through this and there's gonna be a bunch of different physical or chemical changes. So at home, try to call it out as you see what is happening. Is there some type of chemical reaction happening causing things to become something new? Or is it a physical change like me chopping up that wood? So I'm gonna step over here, I'm gonna hit play, and then I'll give you a chance to guess, and then I'm gonna throw out what it is. All right, so physical change is a change in appearance only. And I think we're gonna go with the chemical change over here. So, like temperature changing is a physical change, like, bones breaking, that'd be a physical change. Taking a mixture and separating out the mixture, physical change. Chemical change, electrons are exchanged and a new substance is created. Bang, and explodes. So let's check this out. Should jump right ahead. All right, so obviously, did it become something new? No, it just got broken. So that'd be a perfect example of a physical change, you guys. All right, so now we have heat created. It is exploding. This would be an example of a chemical change. The chemicals in that firework are changing to something else. All right, so there's our Coke and our Mentos, right? And it's spraying off. If it fizzes like that, that's telling us that was a chemical change. All right, we'll do getting his haircut right here. That's just a physical change. Just a little snip with the scissors. That's physically changing it. All right, and now we got some sodium and water, and it's creating heat. It's even catching on fire, and then it is exploding. So what do you think, physical or chemical? Yeah, it'd be chemical. All right, now we got some ice here, and the ice is melting. You see the water drops right there? So obviously it's not a chemical change. It's not becoming something new. That would have been a physical change. All right, so all of these things have been added, and it's changed the colors of the liquids, becoming something new. So if it becomes something new, is that physical or chemical? All right, hopefully you said chemical. Sweet. All right, putting a little sugar and some tea right there. What do you think, physical or chemical? Awesome. Hopefully you said physical, because all it's doing is dissolving that sugar, and we could remove the liquid and make the sugar stay in the bowl. And right here, we're just taking this metal, we're pounding it out, making it into a new shape, but it's not becoming something different. So that would be an example of a physical change. Awesome. I'll have a new video up for you guys for our next science lesson, and hope you guys are enjoying this as much as you can. Hey, go outside, run around. It's a beautiful day right now. Get some fun on. Hope you guys had a great spring break, and I will talk to you later.